Hello everyone. Today I am here to present about the topic of automatic generation of algebraic representation for physics problems. I am Krishnendu Ghosh, Assistant Professor in the Department of Computer Science and Engineering in Techno International New Town, Kolkata. This is the content of my presentation. First we will discuss about the introduction, literature survey, then we will discuss the proposed method, how we evaluate the system, and then we will present our findings and finally conclude it. In the introduction, first we will talk about the physics word problem. So physics word problem is any problem which is any word problem in the physics domain. And algebraic representation is the representation of the physics word problem in using some equation. And in this equation there will be variables, and some variables will be known, some will be unknown. They will be connected via some operator. So when we have surveyed different literature in the physics word problem domain, we have found 4 different type of representation: literal, naive, scientific and algebraic. As we have learned about this representation, we have seen that these are the different representation that based on the how a particular student perceives a physics word problem. As their expertise is more and more, they can see the different problem in more generic form or generic way. As an example, we can say if a problem is saying that one rocket is moving, and in another problem it maybe there is a car moving. So for both of the cases, if we want to represent both the problem using a equation, then there might be no difference, because the equation will have the value or the variables that will not have the terminologies like rocket or ball or any other object. So when we are talking about some representation of higher form which are for the expert or motivated or learned people, so those will be more towards the algebraic representation. And when we are talking about novice students who don't have much idea about physics problem, then we are talking about some representation which is more of textual form, which are more towards literal representation. So we'll discuss with example all this representation in the following slides. So one example we are constantly following here: a 5-gram bullet leaves the muzzle of the rifle with a speed of 320 meter per second. The expanding gases behind it exert what force on the bullet while it is traveling down the barrel of the rifle, which is 0.820 meter long. So this is the word problem. So in this word problem you can see different parameters or variables are there, and in this variable some variables are known, so the values are present for them, and some are unknown, which has to be determined finally as a result of solving this particular word problem. So if we are talking about what should be the literal representation for this particular word problem, it will give us the keywords. For example, bullet, rifle, force, barrel, constant acceleration or negligible friction. If we are talking about naive representation, so this type of representation gives an idea about the schematics or the spatial relationship between the different objects present in this particular problem. For example, we are having here one bullet, and that is present inside the muzzle of the rifle, and it is moving down the barrel of the rifle. So somehow the bullet is inside the muzzle of the rifle, so this information is present in this naive representation. Or if we are talking about two blocks, one block is situated on another, so this type of information or spatial relationship is presented. When we are talking about the next representation, which is scientific representation, then we are giving the idea that what are the different laws of physics that is involved in this particular case. So this will give us idea that what should be the equation or what should be the chapter which we should read so that we can learn about or we can solve this particular problem. So in this case, for this problem, we can say like laws of motion, concept of force, concept of acceleration. These are the different concept of physics that are mentioned in this scientific representation. Coming to the final one, which is the algebraic representation, which is the focus of our study in this case. There two different equations have been used: F equals to ma, which is force equals to mass into acceleration, and the second one is v square equals to u square into minus 2as. So where v is the final velocity, u is the initial velocity, and s is the distance covered. So we can understand we have to finally determine what force. So force or F we have to determine. So in this equation obviously we can understand F is unknown. So for F to be known, M and A should be known, but M is given here as 5 gram of bullet, but the acceleration is unknown. The acceleration therefore you have to determine from this second equation as the v, u and s. These three information or variable is known in this particular case. Okay, so the main thing what we want to say here about algebraic representation is for different word problems there may be the same type of algebraic representation if we will generalize the problem way too long. There is another example given here, a rather simple one. A force of 10 Newton is applied on a block having mass of 5 kg. What would be the acceleration generated? So for this one, obviously the equation will be F equals to m into a. So then we'll discuss about the different relevance of this particular algebraic representation. Why it is important? This can be important because there are several applications like automatic problem generation, guided problem solving, automatic hint generation, student diagnostic and feedback, and automatic grading. When we are automatically generating a particular problem, we can understand we have a repository, we have several problems, but for customized question generation or so that we can give different problem to different students based on their expertise level or so that they cannot copy from each other, so we have to generate a lot more problems, but manually calculating or generating all those problems every time it might be difficult. So that's why what can we do? We can automatically generate them. So for automatically generate them, you should understand what is the basis of this particular problem, and the basis is known as the algebraic representation in this particular case. If we want to use a guided problem solver, okay, if you want to develop this, then what will be the problem? For this one, if you know the algebraic representation, then what will be the equation, what is known and what is unknown. Based on that, step by step, what should be solved in each step, that you can guide. So that can help for the building a guided problem solver as well as the hint generator also. Okay, now based on in which particular case or topic the students are lagging behind, a diagnostic and feedback system also can be generated, and finally obviously we can automatically grade based on what is present in the student answer and what is present in the model answer by comparing both of them. Okay, so we can understand the relevance of the problem or the algebraic representation. So as we have surveyed the literature in this particular domain as well as in other domain also. In other domain, all the papers that we have read, those are mostly based on the algebra word problems. Mostly they are based on English. So we have read many papers, but mostly they have used three different approaches, and these three approaches have been used by Singh et al., Wang et al., and Jai et al. Singh et al. Used the approach of query generation, execution and tuning. Okay, so in this case what they have done is the word problem itself they are considering as a document, and the algebraic representation they are considering as a query. So when they are generating the query, so it means from the word problem they are generating the algebraic representation. After generating the algebraic equation, they are executing it. Executing it means they are searching. They are searching with the algebraic representation so that they can get the algebra word problem itself or some other problem which are of similar type, and then they are tuning based on their requirement. So if you have to create the different version of the same problem, you simply can tune it and you can generate a lot more. Similarly, there is another approach which was using expression tree. So in the expression tree based approach, the basic idea was to generate the solving path of a particular problem, and another approach was based on complex relation extraction. So there are some other cases for Hindi also, algebra word problem they have tried to solve. They have created some repository also. So these are all about the other domain. Then we will talk about the what in physics domain people have done. So first type of work what we have surveyed, they are giving the representation and they are giving the idea that how one particular physics problem can be solved by using students or experts. So Chai et al. And Haworth et al., they have given us the 4-layered representation. So what are the different ways so that we can step by step how much we can abstract a particular physics problem they have showed us. After that we have read another paper by Kuo et al., which has discussed about the problem difficulty. So they have actually tried to identify what is the different parameter present in the problem, and based on that they try to identify the difficulty level of this particular problem. And this paper can be useful if anyone want to generate a problem which is harder than a base problem. Suppose in your classroom you are having expertise level, expertise level of the students are of different levels. Okay, some are motivated and expert students, some are weak students, some are average students. So that based on their level you want to judge them. So you have to generate problems which are having different difficulty levels. So in this case you can use this particular paper and you can get idea about the algebraic representation, how it can be used, and based on the different parameter how the difficulty level of the problem can be determined. Geiger et al., they have discussed how to solve physics problem. So how human beings solve the physics problem. They have tried to identify the path of solving the process, and then based on that how machine can be learned about this particular solution path they have tried to identify. Then there is some repositories also people have tried to create, and then the most important and interesting one, which is using a template generation for problem solving in general. So we have followed this paper to some extent, but they have solved general word problem for this. We have mostly used for this physics domain. Okay. So the challenges that we have faced during this particular case. So as the literature survey has been done, so what we have seen is that there are no standard database and representation for physics domain. Okay, so as the standard database is not there, it's very hard to assess your system against a particular standard. Then there is missing an ontology for the domain specific concept, so which concept is subversion of another concept, understanding that might be difficult. Then capturing domain specific semantics or the meaning will be difficult. Validating equation is difficult. Even if you can get a particular equation, whether that particular equation is correct or not, whether in the equation which is known and which is unknown, that quantities or the parameters are correct or not, understanding that or validating that will be difficult. And there are some additional issues also if you are working on regional language that we are not doing in this particular case. The method we will discuss. In our proposed method we are having two steps: template generation and template tagging. In the template generation, the input will be a pair of word problem and the corresponding equation, and the output will be a template equation where the slots will be either known or unknown. For example, you can see here one word problem is there and the equation is given there. So if these two particular thing are input, the output should be this. So what is a template equation? You can understand from this. This is just looks like the equation, but instead of the value or the a or the variable, we have here some values like n and u. So n are having different subscript like 1, 2. So n1 and n2, those n stands for number and u stands for unknown. So whenever we are having an unknown or more than one unknowns, so that will be termed as u1, u2, u3 like that. And if there will be some numbers, you will note them as n1, n2, n3 like that. So if we are replacing that, so just the form of the equation we are getting, we are not giving a specific values. So that is a generalized form for any of this form of word problem. So if instead of 140 Newton, if some different value will be there, so that also we can instantiate in this template equation. But if we are using this particular equation, then we cannot do that. So just to make it more generalized, we have used the step of template generation. So once the template has been generated, then you have to understand from this word problem and this template generation template, that what is n1 here. Is it 140 or is it 55? Because we know that this is number, so obviously either 140 or 55, but which one? So that you have to generate. So for that we have used the step of template tagging. So for that we have used two approach. One is rule based, another is NER based. In the rule based, what we have seen, that always the numbers will come, or in the vicinity of the number there will be one unit present. For example, here the Newton is present. So whenever it is Newton, we know that this is the unit for force. So that's why this 140 will be the F, which is the N1. So using the information that what is the different unit present, where it is present, whether it is a noun or not, so different rules have been used. So based on these particular rules, we have tried to identify whether a particular n1 or n2 is which number, and if it is unknown, then which is it is. So similarly we have used a NER based approach. So using standard NER model, what we have tried to identify the different named entity we have identified, and this information we have passed. So based on that we have collected a particular database and tested and trained all this information. For template tagging using NER based model, these are the different feature that we have used. Okay, so this is one example for template tagging. As you can see here, the 10 is the force that we have identified, the 5 is the mass that we have identified, and the acceleration is the A in the equation that we have identified. So we have collected a database of 75 word problems from the laws of motion chapter of different books. We have pre-processed and normalized so that different parameters and inconsistencies are not present in the database. And then these are the database statistics. We have divided them into training set and test set, 50 in the training set and 25 in the test set. Then we have evaluated them based on three major parameters: precision, recall and F-score, both the step of template generation and template tagging. For the template generation, these are the result. We have seen 85% of around precision, so which is quite good, we guess. For the template tagging, for the rule based, we have got the performance of 72%, and for NER we have obtained the precision of 65%. So the findings are like this: the rule based approach works better than the NER model. So performance of the rule based approach depends on how good the data is pre-processed and normalized. A concrete ontology or concept map can generate better rules for the training, and all the steps are domain and language dependent. So from these findings, what we can conclude is, this is a preliminary attempt. There is plenty scope for improving the performance using more appropriate formalism, extending the domain to other related domains, collecting more training data. And the training topic is also like ChatGPT and language modules or attention levels. We can try to identify whether we can generate or we can do the application without or with using the algebraic representation or not. So these are some of the reference that we have used. Thank you.